Hi everyone, great to see you all. So today again I'm just going through the answers. I just learned few things into answers that is related to flow simulation by using ANSYS Fluent, Fluent. So here I'll just deal with the mass flow and the temperature variations into the simple flow. Um, like I don't want to waste much time in explaining the things and all, so let's get started with this. I'll just define the study, that is Fluent. If you want, you can rename it here, but I'll keep it like this. I already created the component by using SolidWorks, so I just wanted to import that one. I'll browse it. I don't want to waste my time into this geometry creations. I need to make some changes. I'll just double click on the geometry to get inside the geometry modeler. In a system, I'll set it to mm. I'll update the model so that we can just work on it. So here, as you can see, these are the three inlets and this is the outlet. I'll define my flow, that is standard water, and I'll define the velocity 0.4 meter per second and 1.2 1.2 meter per second from these two inlets. Before that, I need to set the selections so that I can define the parameters inside the boundary conditions in the flows. I just need to create the slice so that I can analyze the results on it. So I'll just choose the slice, and with respect to the base plane is xy, I'll apply this generate. So the slice is there inside. I don't need to hold. Okay, I'll just choose select other option is there or not. I'll just check once. Select loop. Okay, once you click on it, you can able to switch between the things. So I just selected that. So I just want to create a name selection for that is symmetry. I'll define it. Actually, I need to take the section view and I need to start this analysis, but I need the entire model so that it should look good. To consider entire model for my study here, I'll just rename that symmetry so that instead of creating the section view and selecting that face, just define the slice so that I can just have the results on it. No, fine. So that is done. I need to define these two surfaces as my. So first, let me generate that. These are the outlets. I think so. Yes. Outlet. Generate it again. These are the inlets. Name selection. Large inlet. I will rename it because later large inlet. It won't give the space and all. Fine for me. Then this should be bottom inlet, right? Better to rename it properly, otherwise it will be difficult to recall them again, right? Inlet, fine. Top inlet I'll define. I think lateral inlet is fine for that, but it's okay. Fine. Outlet, is it done? Yes, outlet is ready. Inlet, bottom and top inlets are ready. Symmetry also defined. Fine. No issues. So I'll select entire body once so that I think if you create the slice, it will just create two separate bodies. Fine for me, no issues. I'll define the name for this. Let's check. Okay, I don't know what happens for this because I'm doing this for first time. Define it as entire body. Generate this. So we are ready with this. So I think this is the model. Yes. Yep. So I'm done with this. Oh shit. Took two solid bodies. What should I do now? I think it's fine, right? Nice. I will just deal with this. Let's see what happens. I'll define the fluid type as fluid here and like solid type to fluid. So as I'm dealing with flow, regenerate everything again. Okay, fine. Yeah, I'll close this modeler. Once that is done, I'll switch to the meshing. Here it takes time to load up. Direct P. Yep, everything is ready here. I'll just use the mesh, and here this is CFD and Fillent is fine. So the relevant center, I'll make it fine. Smoothing should be high for me. And then element size, then okay. Then I need inflations. So where is it? Here. I'll use the inflations. I need exactly 5 layers so that I can get the proper results. Fine. So I'll add coarsening inside. So sizing with respect to this entire body, this one as well as this. Hold the control and define. This makes me size. Okay, 6 mm is fine. Well, we are done with our meshing and generate this mesh. We'll see how much time it takes to generate. It takes somewhat more time. Well, once the meshing is done, so I need to define the boundary condition for the Fillent flow. That is flow itself. So once I click on mesh, we can able to analyze how they look. So for our clarification, so what here I can do is I'll go to this geometry and just hide one of this for our convenience. So now you can see. So inflation I have added, there are 5 extra layers has been created for our reference. Let it be. I hope you got the point. And then, so let me just show this. So I'm done with this. So I'll just close it. I have updated the things. So I'll just update the project so that okay. Oh shit. The mesh component flow failed. Okay, we check. I think everything is fine. I shouldn't have created the slice. It's like I better to take the section. I feel so. We just try it again. Yeah. Oh god, I hope it gave this. No. Oh, it should not fail. Yes, thanks. So I'll just set up my Fluent study here. I need the double precision, then fine. These are the display options. You can just deal with this, and the processing should be serial for me. I'll just use the defaults. Yep, once you do that, your Fluent workbench will be open. Here I just need to deal with these informations. So it shows the laminar solver has been added automatically. Fine for me. First, in the general, I'll just try with solver should be absolute and the pressure based. Actually, I'm just dealing with the pressure only, and the temperature variations, and the time should be steady. That is fine. So I'll check this meshing first. So whatever the mesh we have created, that I'll check, and once you check it, it shows the done. I'll report it, and maximum minimum aspect ratio is fine for me. Everything is okay over there. I'll just switch to model, and here I am going to deal with energy equations. I'll just double click on it and I'll activate the energy equations for me. Then viscous, laminar is there. Then anything else I need to deal here? Heat exchanger, no. Viscous, yes. My viscous should be with respect to K epsilon. Okay, so that I need to change here. It should not be laminar. I'll explain how this K epsilon and all works, and what actually why we need to define this K epsilon for the studies and all. I'll just go with that later. And the standard wall functions, no. I need to deal with the enhanced wall treatment, so that it should consider the thick wall. Yep, I'm done with my model here. And then material, not the air. I need to define water here. I'll just create new. I'll mention it as water. The properties for the water, I know density it's 1000 and viscosity it's around 0.0008, I think. Conductivity and all, I don't know much about these, so let me just check once. Actually, I have created the properties for that. Yes, it is 4216 is the specific heat for this. 16, fine. So I'm done with my study. I'll just create this, and here in the fluid material I want to replace the air with my water. That is done. So material is done. The shell zone, so it should be fluid. Just try to edit this. So here water has been automatically added as you define the material. Fine. The dynamic mesh is nothing, no need to change these parameters here. Fine. Dynamic mesh, it is not needed right now. In the solutions now, solution method should be simple. Okay, it is not as much as complicated we think. And then here, yes, gradient should not be based on shell. I need like with respect to node. If I say node based, everything is fine. Okay, solution controls, the values of pressure is 0.3, density fine. Okay, turbulent cannot be 0.8, fine. So there is no need to change anything. By default you can keep them. The residuals, I'll just check once. Residual printing, what and all is there. Here I need to plot the graph. Fine. The result should be taken. 1000 iteration is to store. Fine. So no issues. And in the surface monitor, I just want to create one more for me. It should plot the results, and I need 3 iterations. It should follow to give the results. And here my report should be with respect to maximum phase, and the temperature I'll take as my consideration. And here for me with respect to outlet, it should give the result. Okay, the surface should be outlet. I'll click OK. Actually I need to analyze outlet here. Once I define it, just go with this. Here initial hybrid, I need to initialize it, but before that I need to define my studies. Let me just check. Boundary conditions, yep, here I need to define the boundary conditions. Once I define it here, first I'll define the inlet velocity for this. So I'll just use large inlet and I'll edit this. With respect to this large inlet, the velocity specification should be with respect to magnitude, that is components. So oh shit, need to move the component to check the, it is not so fitting at all. Pan, activate the pan and move it like this. अरे भाई क्या चल रहा है ये, zoom out कैसे हो, fine, just a minute guys. This is 2, okay, just want to zoom in, zoom out भाई और थोड़ा, yes, so बहुत हो गया, oh shit, it's gone. Okay, with respect to x direction now, yep, flow is with respect to x direction, that I need to analyze, sorry for that. So inlet should be with respect to x, the component, it should be 0.4 meter per second, fine. And then here the turbulence method with respect to what, diameter, so the diameter is 150, that I know, I'll mention it here, 150 meters, shit. Okay, I need to change the units, not meters, so let me just check my unit system. The general unit should be with respect to length, it should be meters. Meter, I need to change it to millimeters. I think values and all gone wrong, I think I need to recheck everything. I haven't added any value here. I think these values might be changed. No issues with this. I think only here I was dealing with this values, so fine. Where I was, inlet, where is it, large inlet, this one. With respect to what, would have completed this before, I think 0.2 meter per second. If you want, you can make it 0.4 or 3 meter per second with respect to the diameter, 150 mm. So you should note it that the unit should be changed while defining these all the things, very important. The inlet temperature for me, it's 295, not 395, 295, that is room temperature value. Outlet, with respect to outlet, what I need to change here, again the diameter, I need to mention it's 150. Everything is fine, no need to change. Okay, it's 300, bulk flow 300, fine, and by default it was there, I won't change it. Where is bottom inlet, let it this with respect to components. Okay, bottom inlet with respect to, I think, y-axis, so I need to add with respect to y, 1.2 meter per second, I will add it. Oh, the diameter, I know the value, it's 30, and the temperature should, I need to change its respect to 13.15, I'll change the value. Where is the top one, top inlet, I need to modify this, same thing, it should be 313.5 for me, sorry, it's 313.5 and the velocity with respect to component, this is with respect to x again, so it should be 1.2. Diameter 30. Okay, I think the boundary conditions are fine. Inlet I defined, outlet I defined, no issues with others. Dynamic mesh is not required. Solutions I was defining. Gaussian node is fine. Standards, no issues. Monitor, I think I need to check whether I have specified any values here. No.
According to the World Health Organization.
Yes, Google now it will start recognizing my voice. I don't know why. Sometimes happens, sometimes no. I think everything is fine, so I'll just initialize the study with respect to hybrid. So standard I don't want because there are so many complications in this model, so I'll just use hybrid initialization for this. Initialization is done, no issues with this. So calculations, let me directly run this one. Before that I'll check this. So it shows there are no issues with this. I'll just close it. If you want, you can just apply that conditions and save that one. So iterations for me for now only 100 is enough. I'll calculate it. I think I have specified everything fine. I don't think there are some issues. Let's see what happens. Okay, the graph started forming with respect to residuals. Oh, yes. Okay, I think it takes some time to give the results with respect to 100 iterations. So until then, I'll just pause the video, guys. Few more studies I have just ran at that is 100. If I run at 200 more, it will convert somewhere and it will give the exact results. For now, this is fine for me. You can just check the residual scales. So they are also starting it converging with respect to their XYZ velocities and all. Fine. I'll switch to the graphics and the animations to get the results. Here I need the contour result. I'll just set up which should be filled with respect to symmetry. I need the results. Pressure, fine. Display this. You can see this is how the pressure is changing on the symmetry. And even you can opt for velocity. Update this. This is how the velocity is changing. So here you won't get more refined results. Here also, this is fine for us, but ANSYS what the results tab is very advanced, so we'll use it now. So why to worry about this? I'll just update this project and we'll just quickly jump into this results. I'll just close this for my convenience to just reduce the RAM usage. Okay, we're into the results. We'll just analyze the results, how we got and what are the velocity and pressure distributions. First let me just check with the contours. The contour one I don't want to rename it, it takes time. So domain on all domains and inlet, no on symmetry. You can see how it is considering. And what? Okay, the contour it is giving with respect to pressure. Okay, variable is the pressure. Just display this. This is how it looks. I'll change it to velocity, otherwise temperature variation. Let's see. Oh shit. Temperature distribution is like this, fine. And then velocity is like this. So this is about just display of contour. I'll deal with the streamlines. We'll check how they work. To float, I'll again consider the symmetry and with respect to velocity variable, apply it. With respect to symmetry it is taking, I'll change it to total body. Is it taking? I'll apply it first, we'll see. No, it is not considering. Yeah, it gave with respect to body. Here I need to uncheck the results, which and all I don't want. The contours I don't want. The wall I need. Default legends I need. This I need, so that I need the detailed output over there. So I'll just use this streamline one, double click on it, and just use the maximum points up to 300. Apply. You can see now. So this is how they distribute, how the flow is happening. So this is a streamline, so it is showing whether if you want to get the animation, just click on the animation, and here streamline one is activated. I'll just select that. I'll reduce the speed. I'll just play the animation. This is how it works. I'll just pause it now. Then there are so many graphs, like there are so many displays, counters, streamline, vector, everything is there. You can just deal with each and everything. Right now I'm just giving some introduction, so how you can just get to know and how to get the results with respect to our requirement. Particle track, I'll just try with this particle track. I don't want the animation for this. Just close it. Particle track with respect to maximum tracks, I'll mention 100 again. Display. Oh, sorry, I don't think it will work here. It will work there. Yeah, vector distribution, I'll see. With respect to entire body, vortex should be there, and velocity. Apply this, and you can uncheck the streamline to check how they are distributing. Even you can hide the body from there. I think here you cannot. You can get the results with respect to that, the face, asymmetry, and these all things and all. So let me just say I just need the results with respect to what? Outlet. Where is the outlet? Outlet is here. Apply like this. Okay, so this is how the results and all works. I hope this video will help you to get in detail knowledge about this. Thank you for watching. Please do support and subscribe our channel. Bye everyone.